Next is a cylindrical shell that is rotating in x-axis. So in our situation, the cylindrical shell is rotating in x-axis. So we have a curve. The limit of integration is from A to B. And like what I've said earlier, the rectangle shape should be drawn parallel to the axis of rotation. And in our situation, the cylindrical shell is rotating in x-axis, so we will be drawing the rectangle shape parallel to x-axis. So the distance from here to here is the radius, and from here to here is the height. As you observe, the radius is parallel to the y-axis. So we have r is equal to y and h is equal to x. There are also situations where you are given two equations that might change the radius or the height of the cylindrical shell. For example, there are two curves, this one and this is the cylindrical shell. So the height might change. So let's say that it is f of x and this is g of x. So the height of the cylindrical shell is equal to f of x minus g of x. There are also situations like you are given two curves and this is the cylindrical shell. So the height of the cylindrical shell is, let's say this is f of x and this is g of x. G of x minus f of x, that is the height. The radius might also change. For example, like what I said earlier, a typical cylindrical shell has a radius of x if it is rotating in y-axis and y if it's rotating in x-axis. But however, the typical cylinder that I'm talking about is it is rotating at the center, or y is equal to 0 and x is equal to 0. But if the cylindrical shell is rotating at x is equal to 1, so here, hence our radius is 1 minus x.